Software-defined data center is a vision for IT infrastructure that extends virtualization concepts such as abstraction, pooling, and automation to all of the data center unregistered trademark S resources and services to achieve IT as a service. In a software-defined data center, all elements of the infrastructure are networking, storage, CPU and security are virtualized and delivered as a service. While ITaaS may represent an outcome of SDDC, SDDC is differently cast toward integrators and data center builders rather than toward tenants. Software awareness in the infrastructure is not visible to tenants. Because it is a vision with many possible implementation scenarios, SDDC support can be claimed by a wide variety of approaches. Critics see the software-defined data center as a marketing tool and a software-defined hype, noting this variability. Proponents believe that software will define the data centers of the future and accept the SDDC as a work in progress. Analysts project that at least some software-defined data center components will experience strong market growth in the near future. The software-defined networking market is expected to be valued at about $3.7 billion by 2016, compared to $360 million in 2013. IDC estimates that the software-defined storage market is poised to expand faster than any other storage market. Description and core components. The software-defined data center encompasses a variety of concepts and data center infrastructure components, and each component can be provisioned, operated, and managed through an application programming interface. The core architectural components that comprise the software-defined data center include the following: computer virtualization, which is a software implementation of a computer. Software-defined networking, which includes network virtualization, is the process of merging hardware and software resources and networking functionality into a software-based virtual network. Software-defined storage, which includes storage virtualization, suggests a service interface to provision capacity and SLAs for storage, including performance and durability. Management and automation software, enabling an administrator to provision, control, and manage all software-defined data center components. A software-defined data center is not the same thing as a private cloud, since a private cloud only has to offer VM self-service, beneath which it could use traditional provisioning and management. Instead, it imagines the data center that can encompass private, public, and hybrid clouds. Origins and development. Realizing the promise of the software-defined data center could only begin to happen now, because until recently data centers lacked the compute, storage, and networking hardware with the capacity to fully accommodate virtualization. Some observers believe that companies began laying the foundation for software-defined data centers with virtualization. Ben Kerian of Midakera considers Amazon Web Services as a catalyst for the move towards software-defined data centers because it convinced the world that the data center could be abstracted into much smaller units and could be treated as disposable pieces of technology, which in turn could be priced as a utility. Vendors watched Amazon closely and saw how this could apply to the data center of the future. Potential impact. Many consider the software-defined data center to be a radical paradigm shift that transforms the traditionally infrastructure-centric data center, with its focus on ensuring the proper operation of compute, network, and storage elements, into an application or business service-focused environment. The software-defined data center purely revolves around application workload demands, allowing business users to deploy and run their applications in the most efficient and SLA-compliant manner. The potential of the software-defined data center is that companies will no longer need to rely on specialized hardware or hire consultants to install and program hardware in its specialized language. Rather, IT will define applications and all of the resources they require including compute, storage, networking, security, and availability and group all of the required components to create a logical application. Commonly cited benefits of software-defined data centers include improved efficiencies from extending virtualization throughout the data center. increased agility from provisioning applications quickly, improved control over application availability and security through policy-based governance, and the flexibility to run new and existing applications in multiple platforms and clouds. In addition, a software-defined data center implementation could reduce a companion Euro-1 registered trademark's energy usage by enabling servers and other data center hardware to run at decreased power levels or be turned off. Some believe that software-defined data centers improve security by giving organizations more control over their hosted data and security levels, compared to security provided by hosted cloud providers. The software-defined data center is likely to further drive down prices for data center hardware and challenge traditional hardware vendors to develop new ways to differentiate their products through software and services. Challenges: the concepts of software-defined in general, and software-defined data centers in particular, have been dismissed by some as a Euro-EN sense, a Euro-OEM architecture, a Euro and a Euro-OE software-defined hyper-Euro. Some critics believe that only a minority of companies with a Euro-E completely homogeneous IT systems a Euro-1 registered trademark a Euro already in place, such as Yahoo and Google, can transition to software-defined data centers. According to some observers, software-defined data centers want a Euro-1 registered trademark to necessarily eliminate challenges that relate to handling the differences between development and production environments, managing a mix of legacy and new applications, or delivering service-level agreements. Software-defined networking is seen as essential to the software-defined data center, but it is also considered to be the Euro or least mature technology Euro required to enable the software-defined data center. However, a number of companies, including VMware, CipherPath Incorporated, Arista Networks, Cisco, and Microsoft, are working to enable virtual networks that are easily provisioned, extended, and moved across existing physical networks. Widespread adoption of network virtualization will require an industry standard. Currently several competing standards exist. Neutron, the networking component of the open-source OpenStack project, is considered an important piece of the standards puzzle and is expected to play a key role in the evolution of the software-defined data center. Neutron provides an application-level abstraction of network resources and includes an API for plugging in virtual switches. The software-defined data center approach will force IT organizations to adapt. Architecting software-defined environments requires rethinking many IT processes a Euro including automation, metering, and billing Euro, and executing service delivery, service activation, and service assurance. A widespread transition to the SDDC could take years. Enterprise IT will have to become truly business-focused, automatically placing application workloads where they can be best processed. We anticipate that it will take about a decade until the SDDC becomes a reality. However, each step of the journey will lead to efficiency gains and make the IT organization more and more service-oriented. Current status: a number of vendors, including VMware, are actively developing the software-defined data center approach. Other vendors are developing components and standards that enable the software-defined data center. The Open Daylight project has attracted support from vendors including Avaya, H3C, Wind, Arista Networks, Big Switch Networks, Brocade, Cisco, Citrix, CipherPath, Dell, Ericsson, Fujitsu, Hewlett-Packard, IBM, Intel, Juniper Networks, Microsoft, NEC, Nuage Networks, PlumGrid, and Red Hat. Large-scale service providers such as Amazon and Service, which could potentially benefit from improved efficiencies through automation, are considered to be the organizations that are most likely to deploy full-scale software-defined data center implementations. For companies that have already deployed a SDN in the data center, many are now looking to expand those benefits to the WAN. A new category, software-defined WAN, is now emerging with vendors like CloudGenix, VeloCloud and Vita. References. External links: Software-defined cloud computing, architectural elements and open challenges, software-defined data centers, What are unregistered trademarks the buzz all about? What is the software-defined data center and why is it important? What the software-defined data center really means: software-defined data centers could change the IT landscape.